Hello, this question is about the IV graph and solving the circuit. Well, you see that the two resistances are in parallel to each other. The one resistance can be called the ohmic resistance. It is a fixed resistance which is not changing over the range of different voltages and the current, right? But the resistor Y is changing, and there may be the this resistor Y may be the thermistor, okay, which changes due to the change in temperature. It may be the rheostat, which you can change by changing the length of the wire included in a circuit. It can be any resistance, okay. So we see that this is a resistance. Before we solve this question, although it's very easy, I just want to show you what is a fundamental concept, right? So how the resistance of the circuit is changing. So dear students, if I show you the at a different points, right, and we draw the tangent line at this point and then at this point, so we see that the tangent line is becoming more steep. The rise over run value, which is delta I over delta V, this is the rise over run. This is a gradient of this graph, and according to Ohm's law, that is equals to 1 over R. So we see that for this type of curve, the 1 over R is increasing, which is a gradient. So if 1 over R is increasing, which means that the R will be decreasing. Okay. So it means that this curve shows that the resistance of the circuit is decreasing. But you notice that the two resistances are in parallel, and we have to find out the EMF of the cell. All right. And right now the current leaving the cell is 10 milliampere. So it means that the current that is leaving is 10 milliampere. So if the current is 10 milliampere that is leaving, well, that current that is flowing in X and in Y can be different, and if of course that will be different. But one thing is we can say with surety that the voltage, the potential difference is equal on both of them, because both are parallel to each other. Okay, now we have to see that what currents are flowing. So we can start from the one. Let's say the voltage on them is 1 volt. Let's see the test and trial method. Well, if this is a 1 volt on both of them, then the current in the Y will be 0.4. In fact, it is 0.5 ampere. So it means that it is 0.5 ampere, sorry, in the Y, and in X is 2 ampere. So you know that if we add 2 and 0.5, it is not 10, it is not 10 milliampere. So we can cross the 1 volt. We can check at the 2.5 volts. So 2.5 volt is this one. So at the 2.5 volt, the current through this is this value, whereas the current through the X is how much? This is 5 milliampere. So you see that the 5 milliampere, and it is approximately 2.8 milliampere. 2.8 milliampere. Their sum are not equal to 10. So you can also cross this possibility. What about the 3 volt? Let's assume the voltage on both of them is 3 volt. So at the 3 volts, kindly check that at the Y current is 4 milliampere. Okay, the current to the Y is how much? 4 milliampere. And the current through the X is, which is ohmic resistance, is 6 milliampere. So that is 6 milliampere, and which is exactly becoming 10 milliampere when they will join at this point. So that should be correct answer. So the EMF is equals to 3 volts.